All right, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 109 is on the screen. That shouldn't take you long. Once again, this is just practice for you. Let's get started, please. And today we're moving on, so stay focused. Put away those mobile devices. Hi, Marley. What's up, Danny? Martin. All right. Copy it. We got to go. We got to go. We're moving on. All right, good communication. My goodness. All right, number 1A, Jacob squared. What'd you get? $12 squared root of 2? 2 squared root of 6. What a save. There you go. That is correct. 2 squared root of 6. Hands if you got that. All right. Yeah, because it was 4 times 6. That's 24. Square root of 4 is 2. So there you go. Let's go to 1B. 1B. Pass someone. Jacob squared. Brandon. Felix. Nice. All right, before we go to Brandon, share with your neighbors, see what you got for 1B. What you get for 1B. 1B. All right. Go ahead, Brandon. That is correct. Let's go. From the corner. Good save. So now we need some difference in product. Check with your neighbors to make sure they got those 3 for the complex numbers. Then we're going to number 3 with the factors of that. Check with the neighbors, see what they got for factors, and Brandon's going to pass it to someone. Go ahead, Brandon. Anthony. Cross it up. X minus 3 and X what? Plus 15. That is correct. Hands if you got that. All right, double check your work. And by now I'm giving you practice on these. Keep that for yourself. But I do want a slope-intercept form equation. Just for the sake of time, I'm moving on. Y equals mx plus b. So, check with the neighbor, see what you got for that one, the slope and the plus b, your equation, and then Jay is going to pass it to someone. All right, Jay. Who? Bailey. Y equals blank X blank. Negative 1x plus 1. Let's double check. So let me put 3 over 2 minus minus 1 over 0. This is 2 over 2. So the slope is actually positive 1. So close. Positive 1x. So then we substitute that in here. So we end up with 1 times x plus b. Oh, but let me substitute for x and y. So I'm going to use this one. X is 0. Y is 1. So this is 1 equals b. So therefore, that is correct. Just a minus on that slope was a positive. Thank you, Bailey. All right, copy the agenda, please. Warm-up 109, polynomial functions. And tonight's home play sheet, only odds. Only odds. All right, as you're sending that in, give me a second. All right, so copy this code on the screen for your access to the home play. 23 WMK. 23 WMK. All right. So, with that said, get a Cornell note ready. Oh, my bad. Hold on. Last night's home play was that. Get that in front of you, please. And for today, I'm actually not going to take this in on Canvas. It's free from me to you, but I do want to see what you did. So let me send you the screen on Nearpod so you can take a picture and send me your work. Give me a second. All right, here we go. Cornell notes, and it reads, I can graph polynomial functions. Today we're still in the middle of graphing and writing, but we had plenty of practice. Now we're going to put everything together that we did right before the spring break and everything we've done so far this week. Okay? So, you don't need a Freire model because you already know what polynomial functions are. Is that correct? So tell your neighbor a definition for polynomial functions. A definition for polynomial functions. Ooh-wee. And I hear y'all. Yeah, standard form, polynomial, and function form. That is correct. There it is. This is what they look like. This is what they don't. We got those notes, yes? All right. And then look up to the screen. Let me pause the tunes really quick. Look up. Before we went to break, we talked about the rational zeros theorem. Is that correct? And it looks something like this. And I asked you guys not to copy it, and I said, let me give you what it means. So then I gave you guys a problem, and we found the factors using that theorem. So now let's put everything together. So write this down, example 1, and write this function. F of x equals x to the fourth plus 3x cubed minus 4x squared minus 12x. Copy that really quick. All right, so here we go. It says, find the zeros of the polynomial function and graph. So now we should be able to do the whole thing, yes? Yes, Mr. Q. So, everybody, tell your neighbor what step 1 would be for this. Step 1. Yeah, change f of x to 0. Tweezy, let's go. X to the fourth plus 3x cubed minus 4x squared minus 12x. All right. Now, here's a reminder. We need to find the fraction to get us started out of this, okay? But before that, since this does not have a constant, we're going to check to see if there's GCF for the polynomial. Look at it. Tell your neighbor what would be GCF for this polynomial. What would be GCF? All right. Looks like Claire's got it. All right. But we're going with Bree. What'd you get, Bree? X is correct. So let's bring out the GCF. And we're left with x cubed plus 3x squared minus 4x minus 12. And all that equal to 0. So, just to focus, if you have a highlighter, right now I'm going to focus in here now. In here. All right? So, the theorem stated that if I use the constant, look up, the constant here is what? Negative 12. So I'm going to write it over here. Negative 12 over, what is its leading coefficient? What is the invisible number here? A 1. So I'm going to put plus, minus, and I'm going to find all the factors of 12. So 1 times 12. What other pairs of factors? 2 times 6. What other pairs of factors? 3 and 4. And since it's over 1, I'm just going to leave it like that. So those are all possible zeros for this. So with that said, y'all ready? So I'm going to start with, I'm going to use blue for positive 1. Positive 1. So I'm going to write 1. That's my divisor. And I'm going to write all my coefficients, including the constant. So what is my coefficient here? 1. Coefficient here, 3. Coefficient there, negative 4. Coefficient there, negative 12. Are we there so far? All right? You all right over there, Jay? Okay. Bring down the 1. Here we go. It's going to go pretty fast. What is 1 times 1? 1. It goes right above. Combine, that is 4. What is 1 times 4? 4. It goes right above. Combine, that's 0. What is 1 times 0? 0. We're left with negative 12. There's a remainder, so this is not our 0. I'm going to switch to red. Why? Because now I'm going to try negative 1. Negative 1. So I write here negative 1. Again, I bring down the 1, the 3, negative 4, negative 12. So I'm trying negative 1 now. Bring down the 1. What is negative 1 times 1? Negative 1. Combine, that's 2. Negative 1 times 2 is negative 2. Combine, that's negative 6. Negative 1 times negative 6, it's positive 6. Combine, that's negative 6. It's a remainder, so this is not my 0. So, what did we just notice, guys? That 1 is not our 0. What are we going to try next? Yeah, positive 2. Switch to blue again. Positive 2. So we got 1, 3, negative 4, negative 12. All right. So bring down the 1. 2 times 1 is 2. Combine, that's 5. 2 times 5 is 10. Combine, that's 6. 2 times 6 is 12. And guess what? This is my 0. Because our remainder is 0. Did everybody see that? Yes? All right. Let me pause the music. Here it goes. So pay attention so like that you can see the transition where we're going. Okay? So writing utensils down, look up to the screen. You'll have time to copy. Look up, please. Writing utensils down. Hands off the keyboard. Look up. Ah! All right, here we go. What was our GCF? X. So I'm going to bring that down. X. They equal the 0. We said we were working in here. Is that correct? So since we found our 0, how do I write this as a factor? X minus 2. Is that correct? All right. And that leaves us with this. We started with a cubic. That means this is what? Tell your neighbor, what is that? Yes, x squared. So what is this? 5x. And then plus 6. So that's going to be my next factor. Copy that. Here goes the most important part of the lesson. Here it goes. So we have factors x, x minus 2, but this is not factored. But look at it. And your brain is trying to do something. Is that correct? Tell your neighbor what your brain is trying to do for that. Let's go. We got 6 and 5. What are factors of 6 that add up to 5, everyone? 2 and 3. So my factors are x plus 2, x plus 3, bring down the x minus 2, bring down the x equal to 0. So What are we needing to do, Mr. Q? Well, at the end, they're asking us to graph. So, remind your neighbor what to do from here. What's the next step? What is the next step? And then Jay's going to enlighten us. What is the next step? Jay. Let's go. X equal to 0. X minus 2 equal to 0. X plus 2 equal to 0. X plus 3 equal to 0. Okay. So therefore, let's solve. This one's already solved. This one plus 2 plus 2. X equals 2. Minus 2 minus 2. X equals negative 2. Minus 3 minus 3. X equals negative 3. And now we can graph, yes? All right. So let me scoot up a little bit. Here it goes. So my x-intercepts, x equals 0 right there. This one's done. Next one, x equals 2. 1, 2. There it is. Next one, x equals negative 2. 1, 2. There it is. X equals negative 3. There it is. Now, how many x-intercepts do we have? 4 of them, is that correct? So parent function should be x equals x to the 4th. Tell your neighbor where it starts, and tell your neighbor where it ends. Where does it start, and where does it end? Where does it start, and where does it end? All right. Jay, pass someone. Brandon Felix not here. Let's go with Brandon Darty. Where does it start? Where does it end? 2 and 1. That is correct. So let's go from left to right. Bam, 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 bam. Let's go. From 1 to 5, how comfortable are you with this? See where you're at? I see some 4s, 4.5s, 5s, 5s. Some of you have weird fingers, okay? So, I'm going to send you the screen so you can send me your notes. Give me a second. All right, just to double check to see the whole process, look up to the screen. We started with a polynomial function, but if we notice, it's not in factored form, so the first step set it equal to 0. To factor this huge polynomial function, we first checked for GCF. Is that correct? And what was GCF? Well, Bree said x, Mr. Q. All right, so we got x out. We're left with x cubed plus 3x squared minus 4x minus 12. Then I said we're going to focus in here using this theorem. So we use the constant, which is negative 12, the coefficient, which was 1, found all the factors of 12, and we tried the positive and negative of each till we found our 0, which was here. We brought down the GCF, we wrote down our 0 here, and whatever was left, there it is. Your brain said to factor, we use Power Rangers, there it is. And the rest was history. Set each one equal to 0, as Jay said. We found our x-intercepts, and we graphed using our parent function. And there you go. Okay. Pretty good, yeah? All right. Man, right on time for Friday. Let's go. Let's go. Copy this one. Example 1Q. G of x equals x to the 4th plus 2x cubed minus 9x squared minus 18x. Almost exactly to the T, the same as what we just did. I'm going to give you a head start so you can get started. Then I'm going to get someone to get us started, and Brandon Doherty's going to pass it to that person in a little bit. So I'll give you a head start. Go. So, since you already checked with your neighbor, see where they were, Brandon Doherty's going to pass it to someone so they can help me get started. All right, Brandon, pass someone. Anthony D. Next step. Set equal to 0, x to the fourth plus 2x cubed minus 9x squared minus 18x. What would be the next step? Greatest common factor, what is that? X, that leaves us with x cubed plus 2x squared minus 9x minus 18. And all that is equal to 0. Now we're going in the inside right here. Let me just highlight it. We're going to use our zero rational theorem, which says we need a fraction, right? What goes on top, Anthony? Negative 18. And underneath? 1, because of the leading coefficient here, it's invisible. All right? So factors for 18. Here we go. 1 times 18, 2 times 9, and 3 times 6. Are those all of them? Yes. All over 1, since we already have them. All right. So far, so good. Hands up if you got up to right there. All right. Next, share with your neighbor what they did right after, because Anthony D is going to pass it to someone to continue. Check your work. All right. Anthony D, pass someone. Claire, what do I do next? Positive 1 is our divisor. That is correct. So positive 1. And then we're going to use the coefficients and everything from here, and including that constant. So 1, 2, negative 9, negative 18. 1, 2, negative 9, negative 18. And let's do our synthetic division. Bring this 1 down, and it's going fast. Here we go. 1 times 1 is 1. Combine, that's 3. 1 times 3 is 3. Combine, that's negative 6. 1 times negative 6. Combine, that's negative 24. This is not my 0. What do I do next, Claire? To negative 1. All right, so negative 1, 1, 2, negative 9, negative 18. Let's try that. Negative 1 times 1 is negative 1. Combine, that's 1. Negative 1 times 1 is negative 1. Combine, that's negative 10. Negative 1 times negative 10 is positive 10. Combine, that's negative 8. This is not my 0. What do I do next? Tell your neighbor what to do next, and then Claire's going to pass it to someone. All right, Claire, pass someone. Bree, what do I do next? Try positive 2. All right, as my divisor. So 2, we got 1, 2, negative 9, negative 18. Let's try that. 2 times 1 is 2. Combine, that's 4. 2 times 4 is 8. Combine, that's negative 1. 2 times negative 1 is negative 2. Combine, that's negative 20. This is not my 0. What do I do next? Free. Try negative 2. So we do negative 2. 1, 2, negative 9, negative 18. Let's see. Negative 2 times 1 is negative 2. Combine, that's 0. Negative 2 times 0 is 0. Combine, that's negative 9. Negative 2 times negative 9 is positive 18, and that is my 0. That is correct. Okay. So I need to write something over here. Tell your neighbor what to write now that we have this, this, and this. Tell your neighbor what to write there. And then Bree's going to pass it to someone. All right, pass someone, Bree. Anthony D. Tell me what to write. What is it? X plus 2. X squared minus 9x. So this is x squared plus 0x minus 9. Oh, minus 9. My bad. Minus 9. Yeah, you can write it like this as well since there's no x. All right. Not bad at all. Let's go. However, is this completely factored? You're like, wait a minute, Mr. Q, my brain wants to do something here. Tell your neighbor what your brain wants to do there. What does your brain have to do there? And Anthony D is going to pass it to someone. Pass on one, Anthony D. Claire, what do we do for this part? Factor, so that becomes x plus 3 and x minus 3. That is correct. This is the difference of squares. Bring down the x plus 2, bring down the x, and all that equal to 0. All right. Let me pick someone to help me out for the next steps. How about we go with Anthony E. What do I do next, Anthony E, since you're fully focused and concentrated like orange juice? Get it? Because it's from concentrate. Anthony E, go! Set them all to 0. X equal to 0. X plus 2 equal to 0. X plus 3 equal to 0. X minus 3 equal to 0. All right. So, for the sake of time, here we go. This is solved. Minus 2 minus 2. X equals negative 2. Minus 3 minus 3. X equals negative 3. Plus 3 plus 3. X equals 3. Let's graph this. Here we go. 0. Done. Negative 2. Done. Negative 3. Done. Positive 3. Done. How many x's do we have? 4. So this is parent function x to the 4th. Therefore, where do we start? Writing. Second, yes, and we end at 1. So, left to right, bam, 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 bam. From 1 to 5, how comfortable are you with this? 5 fourths, 5 fourths. Okay, I think we got this. Let me send you the screen so you can send me your copious notes. All right, so I think we got this. So let's go and backtrack our steps once again. We started with a polynomial function. From there, we set it equal to 0. We checked for GCF because we need to factor. Then we focus on the inside, use our rational zeros theorem, found all the different factors. We started with 1, then went to negative 1, 2, then to negative 2, found out that this is our 0. So the opposite of negative 2 is positive 2. That's why we write x plus 2. We bring down the GCF. We're left with x squared minus 9. We saw that this was a difference of squares, so we wrote x plus 3x minus 3. We have all our factors, set them to 0, solve, graph, and we got it. Yes? All right. Let's move on. Let's go. Copy this one. Example Q. F of x equals x squared plus 2x minus 8. F of x equals x squared plus 2x minus 8. Before Martin goes to the restroom, what is the first step, Martin? Let's go. Equal to 0. 0 x squared plus 2x minus 8. Let me pause that tune. Now look at it. It's a smaller polynomial. And do we need to use the rational zeros? No, tell your neighbor what to do from there. What do we do from there? Ooh-wee. Share with your neighbor, and then Brandon's going to enlighten us. What do we do from there? Brandon. Darty, what do I do? Power Rangers, negative 8 and 2. Factors of negative 8 that add up to 2, everyone. Negative 2 and 4, so 4 and negative 2. So my factors are x plus 4 minus 2, all that equal to 0. What do I do next, David? Equal to 0. X plus 4 equal to 0. X minus 2 equal to 0. Solve for the sake of time. Minus 4 minus 4. X equals negative 4 plus 2 plus 2. X equals 2. Let's graph this. My roots are negative 4 and positive 2. Where do we start? Where do we end? Jacob. There's only 2 roots. 2 x-intercepts, 2 roots. 2 to 1. Yes. Woo. And then, bam. Bam. There it is. Let's go. All right. Good save. All right. Let me see. Oops, sorry. These kind, we did these kind. So now you know all the processes. So if I was to give you this next one, look up. Don't copy it. Just look at it. Say never what you would do with that one, please. What would you do with that one really quick? And then Jacob squared is going to enlighten us. What do we do with that one? Jacob squared. Put f of x to 0, and then? Power Rangers, that is correct, and the rest is history, yes? All right, copy this next one. Example, super cube. F of x equals x cubed plus 6x squared plus 5x. And for the rest of you, I'm going to give you a head start. Share with your neighbor what you're doing really quick, so like that Anthony can get us started with this one. All right, Anthony E. What do I do? Equal to 0. Then GCF, which is x. That is correct. That leaves us with x squared plus xx plus 5. All that equal to 0. So far, so good. Turn to your neighbor, let them know what you did from there, and then Anthony E. is going to pass it to someone. What do we do from there? Anthony E., pass someone. Who? Oh, Anthony G. What do I do from there? Power Rangers for the inside right here. Factors of 5 that add up to 6. Everyone. 5 and 1. So my factors are x plus 5, x plus 1. Bring down the GCF. All right. From there, what do I do? Courtney Jean. Set everything to 0. X plus 5 equal to 0. X plus 1 equal to 0. Let's solve. This one's done. Minus 5 minus 5. X equals negative 5. Minus 1 minus 1. X equals negative 1. Can we graph now? Yes, Mr. Q? Let's do this. Here we go, here we go, here we go, here we go. All right. So we got 0, negative 5, negative 1. All right, tell your neighbor where to start and where to end that graph. Then Courtney Jean's going to pass it to someone. Where do we end? Where do we start? Courtney Jean, pass someone. Selena, where do we start? 3, and we end at 1. That is correct. So from left to right, Bam, bam, bam. All right, go ahead and log out. That was our last example for tonight. Make sure you do your home plate practice. Odds only. What is it? The what? Oh, that's true. All right. Enjoy your home play, everyone. I'll stop the video right here. Bye.